In this video, we will be using the law of sines in order to solve for missing angles and missing sides in right, or actually not, it doesn't have to be a right triangle, it can be in any triangle, okay? So what the law of sines says is that if I have a side length A, I can put it in a ratio with the sine of the angle that's across from it. And that ratio between that angle and that side and the angle that's across from it, the sine of the angle that's across from it, is going to be equal all the way around the triangle. So it's equal to side B over the sine of angle B, and that's the angle across from B, is equal to side C over sine C. So if I draw a triangle, let's say that this side is A, this is B, and this is C. If this is angle A here, then the side length across from it is going to be little a. If this is angle C, the one across from it is going to be little c. And if this is angle B, the side across from it is going to be side length B. Now, of course, when you're looking at a triangle, they're not probably always going to be labeled with little a and big A and little b and big B and stuff. But the point of this is that the angle is related to the side length across from it in a ratio the same way all the way around the triangle. Now I can also flip these over. I could say that sine of A over A, because these are just ratios, right? And ratios are true whether they're upside down or not, as long as they're all upside down. Okay, so that would also be true. Now the way that the law of sines works is that we're going to be looking only at like a portion of it at a time. So I might need to use these two right here. I would never use all three at the same time. Okay, or I might need to use these two, or I might need to use this one and this one together. Okay, so what I want to look for is in a triangle, I want to look for what I have, like what information I know and what I need to know. In order for this to work, I need to know at least 3 of these pieces of information. It doesn't matter which 3, but I would have to know at least 3. If I were using these two here, I would have to know at least 2 of the angles and 1 of the sides, or 2 of the sides and 1 of the angles. I have to know the 3 out of the 4 in order to solve for the last one. Okay, so let's go ahead and do some examples using this law of sines. Let's see. Okay, so I have a triangle here. This is asking me to find side length AC. Okay, so in my law of sines, if this is angle A, I'm going to think of the side length across from it as little a. If this is angle B, I'm going to think of the side length across from it as little b. And angle C gives me little c across from it. Now that means if we're finding AC, we're actually finding side B as it's written in the law of sines. Okay, so because I know the angle across from B, I know this is 103, I'm going to be using B over sine of B as one of the parts of the ratio that I'm looking at. Okay, I don't know what B is, and that's why I put it on top. It's always easiest to put the thing you don't know on the top when you're solving. So because B is what I'm looking for, I'm going to put that on the top. I know what the angle is, angle B, it's 103. So that's one piece of information I know. Now in order for this to work, I need to know both of the other pieces of information. So it looks to me like I either have angle C and side C, or I could use angle A and side A. But I don't know what side A is. I have no way of finding that right now. I also don't know what angle C is, but because I know that the 3 angles in a triangle add up to 180, I can go ahead and add 103 plus 34, which equals 137. And then I can subtract that from 180 to get this other angle. So I know this angle is 43 degrees. So now I know another angle and side across from each other. So I can use C over sine C. Okay, so let's plug in what we know. So again, because it's B I was looking for, I put B on the top. If I were looking for angle B, I would want to flip this over and put sine of angle B on top. So whatever you're not looking for, put it on the top. Sorry, not what you're not looking for, what you are looking for. Put it on the top. And then I'm going to put that over the sine of the angle across from it. So sine of 103. And that's going to be equal to side C, which is 28, over the sine of the angle across from 28, which is 43 degrees. So now, because I know 3 of the 4 pieces of information, now I can solve for B. I can get B all by itself on this side. So in order to undo divided by sine of 103, I would multiply both sides by sine of 103. So they'll cancel here, and I'll just be left with B. So now I can just go ahead and plug into my calculator 28 divided by the sine of 43. Make sure you close the parenthesis on sine 43 when it gives it to you. Times it by sine of 103. Now, one important thing here is make sure, because these angles are given in degrees, you need to make sure your calculator is in degree mode before you do this. Now, I put this into my calculator, and it gives me that B is equal to 40 yards. Right, my side lengths are in yards. Now, when you get an answer, think about it in the context of the problem just to make sure it makes sense. So if this side is 28 and I'm looking for the hypotenuse, I guess this isn't really hypotenuse in the sense that we use it in a right triangle, but it is the longest side, and I can tell that it's the longest side, so it should be a little bit longer than the 28, so it does make sense, right? Okay, so let's try another example. Let's see. So we're, again, finding a side length, so we're looking for the side between A and B. So let's go ahead and label this to match our law of sines. Remember, we have A over sine A equals B over sine B equals C over sine C. And I can flip all of them over too if I need to. So if I'm looking for a missing side, I'm going to use it in this form where the sides are on the top. If I were looking for a missing angle, I would want to flip them over and use them upside down. Okay, so I know that if this is A, then the side across from it is going to be little a. C is going to have little c across from it. B has little b across from it. So I know angle B and I know the side across from it. So that's going to be one of the ones I use. I'm looking for angle C, or not angle C, side length C, and because it says to find AB. So that's what I want to start with, and I want to put that on the top. And so little c over sine 30 would be my first part of the ratio. So I'm using this one, and then because I know side C, because I know angle B and side B, I'm going to use that one as well. I don't need that one, okay? Equals, and side B is equal to 21 over sine of angle B, which would be sine of 61. So as long as I know 3 things here of the 4, then it will work. Again, I use it in this way because C was the thing I didn't know. I want the thing I don't know to be on the top just because it makes solving it really quick and easy. So now all I have to do is multiply by sine 30 on both sides. And then when I plug that into my calculator, it gives me that side C is equal to 12. So 12 kilometers. So this side is 12. All right, let's try another one. Oops, I keep doing that. Okay, so we have, again, a side length. Actually, let's go ahead and go forward till we find one with an angle. There we go. So we want to find the measure of angle A. So I want to use this as little a, the 17 that's across from it. And then I know B, the angle B is 112, and so this little b would be 36. Now this time, because it's the angle I'm looking for, I would want to put the sine of angle A on the top and put the side length that's across from it on the bottom. So over 17. Then I want to set this equal to, and again, because I put the sine of the angle on top, in the first one, I'm going to need to put the sine of the angle on the top on the second one as well. So this will be sine of 112 over 36. Okay, so you need to use the 3 things you know and find the one thing that you don't know. Put the thing that you don't know on the top of the first ratio. Make sure that the subsequent ratios have the same orientation, right? So that if the angles are on the top, the angles are on top again, or if the side is on the top, the side would be on the top all the way throughout. And then again, we only use 2 pieces of the law of sines at a time, although it's true for all three of the sides and angles around the triangle. So here, to solve for sine of A, I would just need to multiply both sides by 17. And then, so the sine of angle A, if I put this into my calculator quickly, sine of 112 divided by 36. Again, make sure you close your parenthesis after 112 in your calculator, then divide by 36, then times by 17. That gives me that it's equal to 0.4378, and I'm going to keep 4 decimal places for now. So this is not just A, this is the sine of angle A is equal to 0.4378. So remember, in order to get A away from sine, I have to undo sine. I have to do the opposite operation of sine. And the opposite operation of sine is sine inverse. So if I take the sine inverse of this side, the sine will cancel out and I'm just left with A. But anything I do to one side of an equation, I have to do to the other. So I would also take the sine inverse of 0.4378. And that's going to give me what angle A is. So sine inverse, I'm just going to put this in my calculator really quickly, of 0.4378 is equal to 25.96. And it's asking me to round it to the nearest tenth. The nearest tenth would be here. And if I look at the number after it, it's bigger than 5, which means this 9 needs to round up to a 10. So rounding this to a tenth would actually give me 26.0 or 26 kilometers. Nope, not kilometers, right? This was the angle. So this angle in here is 26 degrees. Okay. Let's try one more of those, and then we'll let you get back to your life. Okay. Let's do another one where we find an angle. And I'm thinking, okay, let's do this one. So here I'm looking for the measure of angle B. So that's what I'm going to place on the top of my ratio, the sine of angle B. And then, of course, I'm going to put that over the angle, or sorry, the side length that's across from B. So here's B, which makes this right here the side length that I would want. That's going to be equal to the sine of another angle that I know. So I know that this angle in here is 28 degrees. And I'm going to put that over the side length that's across from the 28 degree angle, which would be 33. Okay, so now I just need to multiply both sides by 17. So these will cancel, and then I have sine of B equals, and I'm going to go ahead and get my calculator, sine of 28, close my parenthesis, divided by 33 times 17, gives me 0.241848. It's always a good idea to keep as many decimal places as you can when you're in the mid-step of a problem, because if you don't, then it changes your final answer. The other thing you could do is just take the sine inverse of all of this and do it exactly. So I'm going to do the sine inverse of all of this stuff. And I did keep a lot of decimal places, didn't I? And that's going to be equal to B, which is, let's see, I'm just plugging it in really quickly. And that gives me 13.99, so I'm going to round that to 14 degrees. Okay, so go ahead and give some of these a try. If you have any questions at all, don't hesitate to talk to me or email me, and I hope that you have a great day.